Today we are going to be looking at exponentials. So we're sort of introducing exponentials and talking about how we graph exponentials today. So the first thing that's going to be important is just to understand what an exponential function is. So when we are talking about an exponential function, we are talking about something that is sort of in this format. Okay, and you'll notice the key here is that this exponent is a variable, and that is the key to an exponential. Okay, it has an exponent of x. So instead of it having x squared or x to the third, that x is the exponent. Okay, and when we are graphing exponentials, we are going to have a very couple unique things sort of happen. So I want to sort of really quickly just talk about the graph of an exponential. So when we graph an exponential, it always kind of looks like this swoop shape. I don't have a better word for it. It could be going up, it could be going down, it could be increasing or decreasing. The key is sort of to understand that this isn't sort of a shape that gets wider and wider and wider like a bowl. Instead, with an exponential, we have a very sort of new concept that comes up, and we have something that happens with exponentials that we call an asymptote. Okay, an asymptote is a very oddly spelled word, is a line that we cannot cross. So there's sort of this imaginary line that's happening here where the graph gets closer and closer and closer and closer. Okay, so if it's getting closer to 0, right, it goes to 1 and then a half and then a fourth and then an eighth and then 1/16th and then 1/32nd and then 1/64, right? Tinier and tinier and tinier and tinier, but we don't actually get to that number. So that's what we're sort of looking at today. How can we figure out what this graph looks like and find that line that we can't cross? The good news is that we basically already learned everything we needed to know about graphing these things in our other various functions unit. So we're going to have some of the same properties that we've seen before. We just now need to put it all together into an exponential. Okay, so let's say we want to graph y equals 2 to the x minus 1. The first thing that we are going to learn here is that this number that's being added or subtracted on the end, this piece right here is our asymptote. Okay, so this right here is our asymptote. It's the line we can't cross. And it's always a horizontal line. Okay, so this is always going to be horizontal. It's always going to be right and left. Okay, so that tells us at -1 on the y-axis, because it's going to be horizontal, there's sort of this horizontal line at -1 that we know we can't cross. The rest of this problem, we're going to do just like we were graphing with quadratics. So while we're not going to have a formula for standard form or anything like that, we are going to make a table and we are going to plug in some points. Now, to find good points, my suggestion is that we always sort of start with -1, 0, 1, 2, and 3. The catch is that 3 can get really big really fast and be off the graph. And so we might have to pick something smaller. But just like we did in our last unit, we are going to take these values and we are going to plug them in for x. Okay, so if we plug in -1, instead of saying 2 to the -1 or 2 to the x, we're going to say 2 to the -1 minus 1, right? Instead of saying 2 to the x, we're going to say 2 to the 0 minus 1. 2 to the 1 minus 1, 2 to the second minus 1, and 2 to the third minus 1. Now, if we think all the way back to our properties of exponents unit, which you're going to have to remember that info for your final exam, right? We've talked about how to do some of these things. So yes, absolutely, you can use your calculator to help you. But remember, a negative exponent tells us that it's actually turning it into a fraction. It's moving it to the denominator. Okay, we also learned that anything to the 0 power is always 1. So let's start calculating some of these. So if you don't remember how to do this in your calculator, you're going to type in the number 2, and then you're going to do the up caret, which sort of is to the left and above from the 7. So if you go left of the 7 to the x squared and then one button above, we have that the up caret, -1, and then we'll put in -1. So 2 up caret -1 -1, and that gives us a -0.5 or -1/2. Okay, then we're going to plug in 0. So we'll do 2 up caret 0 -1. And what do we get out? We should get out 0. Okay, then we are going to plug in a 1. And what do we get out when we do 2 to the first -1? We get out 1. Okay, now let's do 2 squared -1. That gives us 3. And 2 to the third -1. This gives us 7. Now, we should know at this point that we can then find ordered pairs from this table, and we can plot those onto the coordinate plane because we already did that in our last unit, right? So we have all of these ordered pairs just going down this table. So I'm going to start from the bottom here. So I'm going to plot my point 3, 7, and then I'm going to plot 2, 3, 1, 1, 0, 0, and -1, -1/2. I have to kind of approximate that point. Okay, but right, I'm halfway in between those points there. Okay. So what we then should see is this sort of swooping that's happening. Oh, wrong button. This swooping that's happening here, like sort of in this shape. Okay, but notice I'm not crossing that line at -1. What you cannot do is come down this way and cross that pink line we made. So we need to make sure we are staying above this asymptote. And there's our graph for y equals 2 to the x -1. Okay, so let's look at another one. Let's say we have something like y equals 4 to the x -8. Okay, so if we want to graph this, we know that we are going to have some type of asymptote. So where is our asymptote going to be on this equation? It will be at -8. So we're going to draw in a line here at -8. This is the line we cannot cross. Okay, and then let's make a table. So we need to make a table to plug in some values. Oh, come on. Sorry, guys. Sort of. Make a table, and we're going to plug in some values. And like I said, let's just start with a -1, a 0, a 1, a 2, and a 3, and let's see what happens. Okay, so we're going to do 4, and instead of x, my x now equals -1. So 4 to the -1 -8. Okay, so when I put that in my calculator, 4 up caret -1 -8, I get -7.75. Okay, so what do we get when we do 4 to the 0 -8? We should get out -7. When we do 4 to the first -8, we get out a -4. What do we get when we plug in 2? We get out 8. And what do we get when we plug in 3? Okay, so here we should pick 56. Do any of these look like a problem? Hopefully in our brains we're saying, oh yeah, 56 is way too large for us to be able to plot. So sometimes if we get a number that's too big, we have to sort of change our minds and say, okay, that won't work. I need to start over and I need to pick something else. Okay, so I need to do something different. Oops, I'm going to extend my table here. And now I'm going to say maybe instead of -1, let's pick something smaller, -2. If I go any bigger, I'm just going to be too large. So now let's plug in -2 and see what we get out. Yep, you're all probably like, I don't think this is right. But we get this weird -7.9 If you want to write down that whole decimal, you can, or we could just change it into a fraction, which is kind of weird as well. Either way, we're going to have to kind of approximate. We don't have much of a choice. And this is something that just happens with exponentials. Okay, sometimes we start to get some really weird numbers. The larger this value is right here, the stranger our numbers are going to get. Okay, so we're just going to do the best with what we have to plot these on our coordinate plane. And it just kind of is what it is at that point. So -1, -7.75. Again, I have to approximate. 0, -7, 1, -4, 2, 8. Here we definitely see that swoop happening. -2. We are almost down here, right? But again, even though we're really, really close to this, we cannot cross it. You definitely see that sharp swoop. And there is our graph. So your job today is going to be to fill in some of these tables and make sure you are getting these correct values so that you could turn them in a graph to graph an exponential function.